Thank you everyone for joining. I'm really excited to be here. This is my second time on PyCon US, second time as a speaker. I'm excited and also a bit nervous, so please be patient. Today, we're going to be talking about T-strings, a new thing that just came up with Python 3.14. Quick, brief introduction about myself. My name is Vinícius Gubiani Ferreira. I am from Brazil, came all the way from Brazil, south of Brazil. Thank you, Brazilians. Long flight, I hate flying. So, work for Asian Technologies. I am a Python specialist at Asian, which is roughly the equivalent of staff engineering. We don't actually have a job as a title as staff engineering, so it's pretty much the same. I am really annoying about quality. That's why that's the picture of the guy cutting grass with scissors in there. I like open source projects. Unfortunately, don't get a chance into doing a lot of open source nowadays. I think the coolest project I worked on was actually translating the Python documentation for Brazilian Portuguese. It was a while ago. Also got a chance to work with Scan API also a long time ago. And among my hobbies, I like craft beer, riding a bike around the park, and you may see in my bio, I also do a lot of reviewing for submissions. So if you submitted something for PyCon US, Python, PyCon Italia, and others, I may have seen your submissions. So thank you, or sorry. So our schedule for today. We're going to start with a brief intro for strings and T-strings, motivations, some personal motivations, goals, what this PEP actually tries to achieve, what it doesn't. Then we're going to move on into T-strings in details, how they work, main properties, methods, what you need to know, what works, what doesn't work. Besides that, benefits and use cases, some of them fairly well known, others maybe not so much. And finally, before wrapping it up, it's not only about the good stuff, we need to talk about the bad stuff about T-strings, and of course, opening for questions if we have any later on. So let's get started. Some introduction, motivations, personal goals. So from PEP 20, also known as the Zen of Python, we are actually introduced that there should be one way, and preferably only one obvious way to do it, which is kind of wrong because with strings, we actually get many different ways of actually dealing with strings. And we've been counting and improving on top of that. And we're going to be seeing some of those during this presentation. So the first one is probably who here actually get a chance to work with this one. Raise your hand just to see. Cool. Wow, lots of folks. This is mostly like for people who got the Python 2 or even the Python 1 version. This is the % syntax. Comes along from since ever, I think. It's just as old as time itself, I think. Reminds a lot of the C language syntax. After that, with Python 2.4, we'll actually introduce it to the old template and the dot substitute method. I'm not even going to ask who knows about this because I never knew about this myself. I discovered this when putting together this presentation. I'm surprised to see why people didn't talk about this. I never heard about this. With Python 3.0, we'll actually introduce it to the dot format and the interpolation, the curly brackets sign, where we're actually replacing stuff inside our string. Later on, with Python 3.6 or the PEP 498, we're introduced to F-strings, with a fancier name, literal string interpolation. So comparing to everything that came before, it looks very slick, simpler, easier to handle compared to the other ones. But F-strings are actually missing some features like security, transformation, customization, etc., which actually bring us to today's presentation, T-strings. Changes a lot, right? It's just a T for an F. So there's a very subtle difference in there. But as we're going to see, there is a lot going on under the hood, changes a lot. So to get started with an example on where F-strings failed, let's call it that way, and T-string came along to help us out, we're going to start with this comic strip. So who here ever saw this once? Okay. It doesn't matter a lot if you saw this before or not, because this is really ancient time. I'm not sure from where this was actually created. The important part with this comic strip is that you know about SQL injection, either because you suffered an attack or because you had to care about SQL injection before. And it goes pretty much something like this, like a bad actor, in this case, not stressed mom, having her coffee, decides to name her kid after a security vulnerability. Why? I don't know. She was bored. Who cares? So, and the objective is to teach someone a lesson. Similar case to this, we get cross-site scripting, or XSS, and I'm going to have to apologize myself because my drawings were terrible, so I had to recur to AI to generate something that was actually presentable. So it's something like this, a bad actor. You can see for his evil smile in there. He managed to get some information to a database, a browser, or in the browser, and later on, another innocent-looking user access it and ends up in a bad situation, losing cookies, tokens, passwords, email, maybe credit cards, anything like that, and goes into a position where he may get some even financial loss or different stuff. And finally, another use case that is very interesting for T-strings is about templates, specifically Jinja templates, Django templates, or similar. Who here actually likes Jinja templates? Raise your hand. Good, lots of people. Good for you. I particularly don't like a lot so much about Jinja templates. Why, you may be wondering? Mostly because as the template grows, the whole logic stands in your presentation layer, which is kind of a mix-up. And also for considerations about user experience. Like when you get an error with templates, it usually goes something like, something went wrong. And that's about it, as good as it gets. Like you don't get like a cool stack trace like we get in newer versions of Python. It's hard to debug, like try to put a PDB in there. Nowadays, I think it's probably better with VS Studio Code or PyCharm, but I am mostly a programmer with Vim myself, so don't get a lot of fancy stuff. And debug, PDB, IPDB, doesn't work. Just dump stuff in your terminal with print, ep, print. Nope, doesn't cut it for me. I like to actually halt program execution and try to understand what's going on, not to just to dump stuff in your terminal. Testing is also something that with Jinja templates becomes a bit of a mess. So that's why we're actually considering to moving some parts of our code from Jinja templates to T-strings, but more about that later on in the presentation. All right, so let's talk about T-strings. The first big change about T-strings, it's more on the language level. We got the string module up until Python 3.14. Is now actually a package. All of the code is actually pulled to a dunder init file. And we also got the template lib.py module in there. So if you just use strings as a regular Python user programmer, that's not going to be much of a difference, except if you maybe try to change stuff in the language itself. So you're going to be having some kind of a hard time into trying to make it backward compatible into earlier releases of Python. A very simple example of T-strings goes something like this. We got a variable, we got a T-string, we try to actually replace it inside our T-string, and we're actually going to be getting a string, right? Except not. We're actually going to get a new type, which is a string.templatelib.template. If we actually compare it with fstring, we get a string, very straightforward. So this is the first big example. T-string doesn't give you a string, it actually gives you an object, so you can later on process it and turn it into a string or anything that you feel like for your very own need. So T-strings actually have two main big attributes that you will use when using them. Those are actually the strings, which are tuples, the static parts that don't change ever throughout the whole life cycle of T-strings and your code. And you also got the interpolation, a tuple of interpolation objects, which are the dynamic parts, the curly brackets where things are actually going to be replaced inside of them. So coming back to our previous example, we got the variable, the T-string. If we actually call the dot strings, we can see we get a tuple with the hello and how are you, the static parts, nothing new in there. If we get the dot interpolation, we get a tuple with just one thing in there, one interpolation object, and all the things that are actually necessary for us to converting this into a string. We can also use the dot values attribute to get the final values into what is actually going to be replaced inside our t-string. Now you may be wondering about this non and empty string over here. What exactly are those? So these are special parameters which allows you to do transformation and specific formatting. You can do, for example, try to cast for ASC characters, and maybe, for example, try to set 2 decimal places in case you're actually using a number. So in this example, it's very simple, straightforward. I'm not going to be using those, so they assume the default value. For each interpolation object, we can also call some very interesting attributes. For example, the dot value gives us the final value on what is actually going to be replaced. The dot expression, the equivalent of where we are replacing. The dot conversion, we're not doing any conversion, so it's none, as we was before. And the dot format spec, also, once again, we're not doing anything very fancy in there, so it's just an empty string. So cool thing about these strings, they're lazy string interpolation, and they actually allow us to check the string before and after the final string. We can actually get the string and check it how exactly it was before, unlike F strings and all the other types that we saw previously. So processing a template string. We got a template string. If we actually use the string method or the dunder string method on top of that, we can actually do that. But it's definitely not going to be the string that we are expecting. It's going to be something very, very weird and confusing, not to say the least. So you need to always have a processing method to do your bidding, your magic, into turning this into an actual string. So it goes something like this. Here's a processing method. We actually pass a template string for it, and we iterate on top of our t-string, and it's going to iterate on top of the static parts and the dynamic parts, the dot interpolation, in the order as they appear on the t-string. The order is actually preserved. So from there, you actually apply pretty much any logic that you feel like. This particular example, what you're actually doing, we're setting the static parts for lowercase and the dynamic parts for uppercase. But you're free to implement any logic that you feel like. Another thing that is actually possible and feasible to do with these strings, you can actually just concatenating them by using the plus sign. We can see we added a t-string with another t-string. We got a longer t-string. And if you call the static parts, we get all of them in a single tuple. Dynamic parts, we get all the dynamic parts, interpolation objects in there. So quickly comparing against each of the other methods that we saw before. Compare against F strings, they look the same, it's just a T for an F, as we saw. F strings, they directly go to string, straightforward, no questions asked. But they unfortunately do not provide any way for you to check onto how they were before your conversion and after. Now, comparing against the old template string, which has been around from Python 2.4, here's the full code. Maybe with the full code, it's actually easier to understand why it's actually not used, I don't know. This one compared to F-string is actually safe. You cannot execute code in there, but it has a more verbose syntax. When you compare it to the dot format method, it's also verbose, longer approach, but it strays ahead for a string, unlike T-strings, which defer it for creating string. And finally, the percent syntax, the old one, I got here on purpose with a syntax error when I was actually creating, so I decided to bring it up. It is very verbose syntax. It looks a lot like the single language, but it kind of gives you the accidental type check, which is something nowadays very used. Like if you pass something in some particular cases, like, I was actually expecting an integer, you're actually going to get an error syntax if you pass a string. So now let's talk about use cases. The first one, I think it's more obvious now, is about security, of course. Particular example, cross-site scripting. So here's a use case where evil user managed to hit us with bad code, is going to do something bad for the users. If we actually use T-strings instead, we're just going to apply a safe HTML code in there, and we're fine. Everything is fine. In case you're wondering how would this safe HTML method go, it'll be something like this. This is almost the complete code because I'm missing the import and actually calling the method itself, but it's pretty much the same idea. We receive a t-string, we iterate on top of it, and we check if it's actually a static part or a dynamic part, and we do the magic itself. In this particular case, what we're actually doing is just escaping the malicious part, the dynamic part where it receives input from the users. Good advice regarding security is don't try to reinvent the wheel. Don't think you are smarter than everybody else. There are like 10 billion people on the planet. If half these people actually code, especially with AI, then there is most certainly likely someone that will outsmart you. So try to go for a centralized solution. So try to use libraries. These libraries are already using t-strings. So check them out later in this presentation, t-string HTML, Ludic, PyHTML Nest, TDOM. And there's also the equivalent for SQL injection, SQL t-string, TSQL. Some of them are already even backporting to Python 3.13 and others. I'm not sure how they actually do it to backport to Python 3.13, but it's something interesting. So please, if you're not actually using Django or any other framework or library for sanitize your data, please consider using this if you're actually using t-strings. Domain-specific language. Remember when I mentioned this earlier in this presentation, so I think now it may be easier to understand where we can actually use t-strings. The idea is actually to break down larger and complex Jinja templates into smaller t-strings and apply the logic that you feel like for security checking. We'll give you the possibility of debugging and writing tests for smaller portions of code instead of just having one large template, which can actually be a bit of a problem. So it is something that we did before with f-strings on 1, 2 projects, and we're actually considering that into t-strings. It's also possible to use t-strings with logging. It'll go something like this. You create 2 classes for actually logging, both of them actually using t-strings. The one on the left is actually for human readable format, just for text itself. And the one on the right is actually for machine readable format. It can be, this case is actually JSON, but it could be tab separated values, comma separated values, any one that you feel like is more feasible for your pipeline that ingests data. And after you create these classes, you just set your logging right there. Use any specific output that you feel like. For this particular case, is standard out and standard error. Call your logger.info, logger.warning, etc. And you got your output, as I mentioned before, with just human readable or JSON output for each case. Now, before we actually wrap it up, we need to talk about the bad parts that are, some of them may be obvious, some of them might not so much. So the first big one, things you should be aware, of course, is with t-strings. There are no automatic string output. You need to have a processing method that converts your t-string into an actual string to be used later on. So there's going to be extra code. It may be looking a lot like boilerplate because it will repeat itself maybe a lot, because it's actually going to be often a division against dynamic parts and static parts. So you may even try to apply dry to not repeat yourself. So it's something that you will notice. What else? Performance. If you are actually worried about performance, yes, you should be. I don't have an actual data to show how bad performance it is, but it's probably going to be something like milliseconds if you're actually using t-strings instead of x-strings, because it is a trade-off. You're actually trading speed for security because you are doing extra checks and allocating memory and deallocating memory, that kind of stuff. So it's something that, of course, you're actually going to be at least a bit slower. As I said before, I don't have actual numbers to show because it depends a lot into every single particular case. So if you are trying to squeeze every milliseconds that you want to spare, so you should go for other methods, but please, please, please be sure that your code is 100% safe. Otherwise, someone will outsmart you eventually. There's also the case for complexity and UX. it's a new type of string for people to actually learn and to understand. Even the name, there is already a legacy template that people may not be much aware. I wasn't aware about that. Never heard about that's legacy old template. Error message is something that may actually happen depending on the library or how you actually implement it. People may think, it's just a string. I'm going to pass a string and you're going to get a stack trace error. You need to figure out to understand, what is this t-string anyway? So you need to fully understand it. There's also the case for partial standardization. Like the PEP itself, it creates ways for you to do conversion, formatting, and security, but it doesn't explicitly tell you how or force you on how to do it. So everyone is free to implement it into any way they feel like, so there may be different ways of actually implementing it. So this is something to also be aware. And some final thoughts. T-strings, they are great for library maintainers, especially for security portion, because they actually become a centralized way of mainstream way of doing security. So as I mentioned before, go for the centralized way. Don't try to reinvent the wheel. Strings interpolations, as we saw, they comes in many different forms, ways, flavors, etc. It is the multiverse of string. You don't actually need to migrate everything for these strings because they may not fit into your daily purpose. But please keep in mind the security part. I think these strings are born mostly for security. So if you are 100% sure and confident in security, it's okay. Go for any other way that you feel like. Up next, libraries. They are already using it, backporting it, and probably will continue to use it on the future. It is something that we are seeing. It will continue to happen. There's also another PEP, which might be released, and I think it's scheduled for Python 3.15, which is very, very looking forward for T-strings, PEP 787, which is using T-strings for subprocess, which is actually pretty much like calling an application from inside Python. It is a possible vector of attacks, like users, evil users, those damn evil users. They actually try to pass over any security breach. So if we can actually be even more secure and actually calling another application, that would actually be great. And there is still early draft on a long horizon. This is not even possible to see how long. There's the strings on a long future. So I brought this up just for the mention because this is actually possible to implement with T-string. There is a package called dedented, would actually like align your code, HTML, XML, etc., which is something that is already possible to do with T-strings. I'm not sure if this PEP is going to move forward. It's an early draft. So this is something that, if you like PEPs, is worth checking out. Other than that, I left out some references just in case someone actually want to go deeper and learn more about T-strings. There are very good references for continuing after this presentation. And just after that, I just want to thank you so much for everyone that actually attended. Thank you, gracias, obrigado, grazie mille, dziękuję, vielen Dank, merci, arigato, shishui, and the last one can do it. If you want to reach out, didn't get a chance to attend this session, you can always reach out for me into any of these ways. Probably the best way is through LinkedIn because email may get into spam or something like that. So, thank you so much.
Thank you so much, Vinny. That was an amazing presentation. Let's give it another round of applause. If you would like to ask any questions, please line up in front of the microphones. I think we have time for about 5 minutes, so please.
Hi. So what happens if you wrap the T-string in a stir? What is the output? It just says stir, and then it has the class instance?
Wrap a T-string is like a curly brackets?
No. Like let's say you just call stir on the template. Does it just show a template instance?
If you call the dot string property?
No. If you just wrap it in the string function.
It's going to dump all the... Hang on. I'm going to roll back. Hang on. Hang it there. This is going to happen. This one is what you mean?
Got it. Yep.
It's... I don't have any way to describe this. It's just a mess.
That makes...
But I think the authors did the best as they can. Perfect. Great.
Real quick, don't
Not a
leave
bug, it's a
yet. Don't
feature.
leave. Everybody stop. We have three of the, great talk, by the way.
Thank
We
you.
have three of the PEP authors here, Jim, Kodai,
Oh.
me. We're going to do an
Thank you.
open space tomorrow at 2. We're going to have the freakiest open space ever. Bring your freaky ideas. You'll hear some freaky ideas and a sprint on Monday. And we'll also hang out afterwards if you want to talk to Jim about the most abstract theory you've ever heard.
Thank you.
One of the things you mentioned is that T-strings have a performance cost. With things like logging, often the performance cost doesn't actually normally hit because you don't necessarily log out all your debug statements in every sort of like when you're running production code. What is the cost of T-strings?
Can you just be closer to the microphone?
Oh, sorry. In cases where you have things like logging, you often don't even run sort of like format your logging statements in every run if you're especially running production code and it's a debug log. What is the cost of T-strings when you're just sort of like not actually using them? You're just having them there so that if you were running it in, let's say, debug mode, it would render.
Okay, that's a good question. Since you're not actually converting the T-strings to create a new string, I think the cost is not going to be so much. Like I mentioned before, I don't have actual numbers to say, but I think every time that you actually call the processing method, you're unfortunately wasting a bit of CPU, at least compared to actual f-strings. So if you just don't log, it is okay. You're not wasting resources. But
You're still technically constructing all the, like, the interpolation objects and everything in between, right? So, like, is there that much cost to those objects? Like, what, in practice in CPython, what is the, like, current behavior? What is performance
I'm
penalty?
going to have to double check on you for that. Sorry, I don't have an answer right now.
Hello. So as you're asking like language or like library developers to start incorporating this new feature, how are you thinking about like the kind of tension between like backwards compatibility and security? Because if you want to support like old style strings, like that's kind of a security issue now.
Yeah, making things backwards compatibility usually gives, my opinion, more work. It's harder than actually implementing the feature. Like, for example, which version Python we're giving support? I think it's only up until 3.10, right? Something like that. So backporting, I think is sometimes the hardest part. For this particular case, it doesn't look like a big change, but I'm actually curious into how the libraries themselves are actually backporting for legacy Python code. I didn't check all the code for the libraries, but I'm curious. I will check on that. But it is some work.
Hey, yeah, great talk.
Thank you.
I see the benefit of the T-strings being an object and being able to access different parts of it. I think that's great. I didn't understand the security aspect of it. The example that I saw seemed like syntactic sugar. It seemed like you could pass a sanitizer into the thing and it'll just handle it for you. I've already been doing sanitization by just putting a function in the f string.
Yeah.
What's the difference? Is it like more efficient somehow to pass it as a parameter, a second parameter, versus just putting in a sanitizer directly into your f string?
Yeah. I can't say it's more secure or less secure because I'm not like a security expert pro.
Shoot,
but,
I'm not either.
Sorry. But my opinion, like if you're already doing sanitization and security on other parts, it's fine. Like you don't do like a second double check or triple check. But if you're not doing, it is a way that you can do it because comparing at least to f-strings, you didn't have like a standardization to do it. You had to do it somewhere else. You're free to implement as you feel like. And with T-strings, we get...
I just created a shared library, just like
cool.
clean SQL.
Cool.
Right? And I do leverage other libraries in that with some other things I didn't think it was covered. And then I'll just wrap whatever I'm putting in the F string with that function.
Yeah, you can do a lot of things in there with your processing method. The cool of processing method, like you don't even need to return the string itself. You can return anything that you feel like, another object, a whole schema for HTML, like XML. So it's not like mandatory. You can do any code that you feel like.
Yeah. I see the benefit with that. I
So-
was just confused about the security part.
Yeah, yeah. The security is not optional. You need to have it somewhere. It can be, yeah, unfortunately it's not. You need to have it either on your T-string processing method or somewhere else in a library, in a framework. So the important part is security first.
And this is in 314, the T-strings?
This is already in 314.
Nice, thanks.
Yeah, thank you. A big thanks for the authors of the PEP who are here. Thank you.